And we're going to continue on today talking about functions for the most part and how to use functions to make your life a lot easier in not only processing but in computer programming in general. Functions and methods are extremely invaluable. Now, functions, the difference between a function and a method, they're very similar in nature. The one thing is that a function has something that returns to you, whereas a method doesn't have a return statement, so I'm not looking for anything returned. But they are very, very similar in nature. So say, for instance, we wanted to make a program here that would take temperature in Fahrenheit and convert it to Celsius. Well, this here is the conversion from Celsius to Fahrenheit to Celsius. Is this Celsius is equal to some degree minus 32 degrees times 5 ninths, and then that's going to print out Celsius. So if we start off with our degrees in Celsius, it's going to be able to produce a bunch of different values here that would be comparison to its counterpart in Fahrenheit. So Fahrenheit at 0 degrees is a negative 17 in Celsius. So let's take a look at this. A lot of this is cut and paste. I can just copy and paste this into a processing program, and we can take a look at it. So let's run this. I just copied it straight from the slide. And here is the output, temperature conversion program, Fahrenheit to Celsius, just as the display in the PowerPoint shows. So if we wanted to look through this a little bit here, we start off at 0. As long as 0 is less than 130, we're going to add 10 to that, and we're going to use that value of I. So I will be jumping up by 10, so 0, 10, 20, 30, 40, etc. You take that value of I, put that in there, minus 32 times 5 ninths, and then print off the value of I, and that is plus the Celsius degree. So there we have I is going to be your Fahrenheit values. So starting off at 0, right here for Fahrenheit. And then the conversion factor of I minus 32 times 5 ninths is going to be your Celsius. So that's kind of how you can do, we can make a function here using temperature pretty soon. I do want to spend a little time on nested loops here. So there are two examples that come with this slide here. It says example 410 and 411. Compare the differences from those. So we have those examples, and we've imported that. So for underneath file examples, remember if you need to add examples, you can do so. It was 410 and 411, I believe. So let's go down to chapter 4, 410 and 411. Okay, so let's see what these two do. Okay, so 410 and 411 are posted right here. We have, in example 411, we have a for loop that looks to be drawing an ellipse, and it's going to be along the y-axis. So this first loop is going to be drawing ellipses along the left-hand vertical side. This bottom loop here looks like it's going to be drawing ellipses on the x-coordinate. So it will be drawing ellipses along the top. If we do this here, run that, we should see our first for loop here. This is creating these four ellipses here. Now they look like arcs, but they're ellipses just because their x and y coordinates are a bit off of the window. This second for loop here is creating this the more horizontal look along the top here of these ellipses as well. Now when we have what is called a nested loop here in example 410. We have very similar code here. The for loops are the same. We have a for loop for the y and a for loop for the x. And we have those nested one inside the other. So this for loop ends here. This for loop, however, is nested inside this original for loop. So when we run this, we're going to see a different picture. It's going to have a bunch of circles being drawn here. Now that's pretty impressive. If we can look at what's going on here, the inner for loop, this for loop does a lot of the work. What happens is we start off here on the outer for loop where y is 0. y is going to be less than or equal to height, and then we're going to go up by 40. Y is going to jump up by 40. So as long as this condition is set here, y is not going to be greater than or equal to greater than height, we are going to immediately jump into this inner for loop, and we're going to execute this completely. So we will draw an ellipse at 0 and 0. Then 0, this y coordinate here will be referenced from this y there. That x will be referenced from this x here. Now, as you can see, the first time through, when we go through this, y will continue to stay at 0. X is being incremented, so this x value on that ellipse will continue to jump by 40 until we get to the width of the screen. When we have done that, we will exit that inner for loop, but we are still within the capacity of the beginning for loop. We are still in the scope of this first for loop. So once we have created a bunch of circles that go horizontally across the x-axis, we bounce out and we look now here, and now y becomes 40. Y increments by 40. 40 is still going to be less than or equal to height, and we will enter back into our inner loop. And we will now then have a new value for y. Our x still starts at 0. Y now is at 40. So we have moved down to our second horizontal line of circles being drawn. This inner loop will go through its duration all the way to the width of the screen. When that expectation or that parameter has been met, it will kick out of this inner loop and go back out again to this outer loop, where y was 40, it's incremented again to 80, so it bounces that down to the third horizontal line of ellipses being drawn. So there's a lot of work being done here in this little bit of code. And what we can do here to really expand on this is to change the size of our window and to really see how fast it is. I'm going to add 1,000 to each x and y coordinates. We are relative height and width, so it should pick that up. And now we have a screen that has many, many, many ellipses on it. So that is one of the great things about coding, is that you can do a lot of work with a little bit of code if you know what you're doing. So this is a nested for loop. And this is not a nested for loop. You can see the difference in what their outputs are. Okay, continuing along, functions and procedures. They're used to perform generalizable and repeatable tasks. So for instance, this particular function is called a print temp function. And all it's going to do is print out a line that says the temperature is a balmy. It's going to grab the temp from these function calls here. It's going to put it into our print line and then add an F to it. So anything that's in quotations, that is just simply writing. It has nothing to do with the coding itself. I could put a bunch of gibberish in here and it wouldn't matter as long as it is within those quotation marks. However, temp is reference to a variable, so it will not be in quotations and it will access that variable from here. This is the print temp function. It accepts the parameter of a temperature, an integer temperature. So I can't have a decimal or anything like that. It has to be a whole number. So you may want to run this, however, it's going to be a little different because you do need to do your void setup. So if I were to simply just take and copy and paste this from our PowerPoint into an example here, let's just try this one that we just did. And I run it, I'm going to get an error here because we are mixing active and static methods. So I need to, what we would want to do is just simply create a void setup. And in my setup, this is where I will declare my functions. I'm going to cut those out and put them right here. Now I have values, and I'm going to call these functions. I'm going to call print temp at 35. I'm going to call print temp at 85. I'm going to call print temp function at 120. It's going to go down into this function. It's going to throw in the new parameters, and it's going to print that out. So I should get 3 print lines here with different temperatures if this does what I expected to do. There it is. So we have 35, 80, and 20. So that's how we can do that example there. We can also invoke a function using a variable. So instead of Having it look the way we did, we can say we have an integer variable called temperature and has a value of 35. We're going to call our print temp function on temperature, and we're going to call it again on this temperature here. So we are just simply using a variable. So let's take a look. I can still use that same program here, I believe, and kind of fiddle around with it a bit. You can't go straight from copying and pasting on there. You do need to put it up into your setup. So let's say we have int temp equals 35. So, and then print temp and probably, yep, that'll work just fine. So I'm going to do an int temp, and then I'm going to do, just have to print it. And I'm going to call temp. And that should just grab that 35 and print it here. So we're going to get these first calls because they're still there, but then I'm going to change my value. I believe this should work. Let's take a look at it real quick. Okay, good. We had our original values, so we had our function of print temp called at 35, 85, and 120. Then I changed my value for temperature. I put it in as 35, and then I called it right there as in temp, and it came up here. So that kind of matches up with that original 35. I'm going to change that to 55 just so that it shows a little bit easier here under the eyes. So there we go. Okay, so the major benefit for defining functions is the flexibility. Suppose you decided to display the temperature in Celsius instead of Fahrenheit. Well, we could create a new function right here that does just the opposite of what we had before. So we can now do another function that will give us temperatures in Fahrenheit if we enter in a temperature in Celsius. So that's kind of a neat little function here. So let's try and figure this one out here. I'm going to create a new function using this though, because I think that I want to have two outputs here. I'm going to have a Fahrenheit function and a Celsius function. So I'm going to go in here. I'm going to keep that function I just got there. I'm going to put it down here. I'm going to make a new function. Print temp, and I'm going to call it C. And it's going to take a temperature value of temp C. This way, I'm going to do a little bit different here. So what I will need to do is to identify another function call. So I'm going to do print temp C, and it will take in the value of temp. So now it's going to convert it. So I will get my temperatures in Fahrenheit, and then I'm going to get my temperatures in Celsius. So right here we have 55, and the temperature in Celsius is 12. So let's call, so my temp right now, so it's a conversion of 55. It calls that into here like that. So if I wanted to do a different value and say maybe I don't want to have 55 being converted, I want to have like say 75 degrees converted. I throw that in there here, and when we come back out, it converts that 75 to 23 degrees in Celsius. So that's kind of a neat little function there. And that is all done real quick. Once you have your functions, once you have the correct algorithm set up, you can do quite a bit using functions. Okay, so we've done a bunch of these things here already. That we've got a lot of outputs. Let's make a calculator function here and see if we can do something like that. Write a program for a simple add, subtract, multiply, and divide. You need functions for addition, subtraction, division, multiplications. You can provide two numbers to the appropriate function, and it will compute and display the result. Okay, so this is our add function. So I'm going to pause for a second, set this up, and then just show you what those all look like. I finished up that calculator program for us real quick. I want to show you what that looks like so you can kind of see how we can do that. So I created 4 functions: an add, a void adds function, a divide, a subtract, and a multiply function. We were given this addition function here. So the addition function takes in 2 parameters, an integer a and an integer b. and it provided those functions there. It will go into its the inner brackets here and calculate out the addition of those. So int C will be the result of adding A and B. So it'll print line, the result of the addition is plus C. It gets it there. So void divide, I just have taken as well two integers. This one here is 6 and 3. C would be the result of the division is C, which I have not actually done well on these because I need to do some more math. So addition there is that A, this needs to be divided by B, this needs to be subtracted, and this needs to be multiplied. So let's run this again and see if our functions are working. There we go. So the addition of those two is 9. The subtraction of 6 and 3 should be 3. The multiplication of 5 and 5 is 25, and the division of 6 and 3 is 2. So that's how you can make a calculator, and all you would need to do is to then input your values up here for addition and subtraction, and it would take care of that for you. So moving along here, we're going to talk about this function exercise number 2. So we need to come up with a start with the Ruba's variable example, and I'm going to give that to you. I have that here, and I'm going to put this in so that you have access to this Ruba variable program, and then you can manipulate it, creating a function using this. So you'll have this as a starter piece right here, this Ruba variable file. And it says here, write a function, draw a Ruba that accepts two integers, center x and center y as parameters, and displays a Ruba at that location. Hint the other variables at the top so that they're visible to the whole program. Call the draw function method to draw the Ruba. Call it again to draw it 2 times. Then you want to write a loop to do 10 Rubas and then maybe 100 Rubas. So this is email. So you have here a function called draw Ruba that has the center x and center y already. So we will need to create a function to call this to draw multiple Rubas. So remember, a function can be called in your setup, and will then be called, the function will take into parameters. For this particular one, I believe it's just going to take in center x and center y, because those are the only things that are really going to change on the drawing of this Ruba, is where it is going to be located. So we need to manipulate that center x and center y to get a flow for this. So I would say the first thing we're going to want to do is run this and see what it produces. It's a Ruba over here on the far left. Okay. So all of this draws that one Ruba. So what you will need to do is create a function that surrounds all of this code and call it a draw Ruba that will accept in, basically it's going to accept in these 2 parameters, center x and center y. So let me set that up for you and I'll be right back. Okay, so we have our variables defined here. Next thing we need to do is our setup, which will go right here. So void setup. And from there, we need to create our function that will incorporate the rest of this code for the most part. So we're going to go and do a void, let's just say, let's get a little more space here, void Ruba, that's going to take in 2 parameters, the center x and y. And what it will do is everything down to here. So when I want to call this event, I do that in my draw method. So I have a new function called Ruba that takes in center X and center Y. Right now that center X and center Y is at 20 and 200, so I'm going to manipulate that a little bit. So I'm going to go down here at the bottom and go void draw. And I'm going to go, let's say 200 by 200. Oh wait, I don't have that. I need to set up my draw method better than that. Sorry, that's not how you do that at all. Void draw, and now that inside that function, I will then call my Aruba and give it its two values, 200x, 200y, and now we run this. Okay, so it shifted it over, you can see. So I have, now maybe I want to draw the original one too, because it does ask that we do 2. That formatting looks pretty bad. So let's just say the first one is at 20. And then the second one is at 20 on the x coordinates. The y coordinates stay the same. So now we should have 2 Rubas being drawn here. Boom, boom. Okay, cool. That is really, really neat. So if I wanted to make a bunch of Rubas, I could do so using more and more of this code. I could just continue to push that down and throw in a new Ruba somewhere. That's one way of doing that, but it's very cumbersome. So then the next thing we want to do is to be thinking about doing a for loop in which the loop does the controlling to draw the 10 and the 100. Now I would suggest your for loop to draw the 10 just be based upon your, like maybe your x-axis, so just do 10 along the horizontal. But when we do 100, I would suggest doing like a nested for loop, so that we can see both of the, we don't want to have 100 Rubas going horizontally along a console. We want to see them. So maybe like a 10 by 10 grid for those Rubas. Okay, so let's build that nested for loop to display our 100 Rubas as expected in our PowerPoint presentation. Okay, so what we had before was coding here to create one line of Rubas using a for loop. And when displayed, we had looking something like this. I did think that we might want to maybe even increase the Y value so that we can see the top of Aruba. Right here. Okay, so if we wanted to make sure we controlled this so that it did actually do 10, which 0 through 9 is 10, so as long as it's less than 10, it's going to create 10 Rubas. Wait, no, that does not work because I is jumping up very, very quickly, so that doesn't work as that does not work. So go back to width. And we can see now by manipulating the width of the screen, we can increase the amount of Rubas being drawn. 1, 2, 3, 4, 5, 6, 7. So our window size, this width is not great enough to house all 10 of those. So let's just say, let's just make it easy on ourselves right at the very beginning. Now let's make a very, very large window so we're able to see whether or not all of those Rubas fit inside that. And I'm believing so. We have more than 10. Plenty of Rubas being drawn here. Okay, so now let's work on our nested for loop so that we can do Rubas not only horizontally, but lines vertically following that. So we're going back down in here to this for loop that we created with our function Ruba at center X, center Y, center X being the I value going through this for loop, and our center Y just hard-coded in it at 100. So what we want to do is we don't want to use that particular line of coding. We're going to nest a for loop in here. Now we can't use I because it is already being used, so let's use the variable name J maybe. We're going to start off at 0 as long as J is less than height we are going to add to j. J is going to equal j. Equal j plus, let's go 150. Now inside this inner loop is where we will call our function for Ruba. So we'll go Ruba. And now we have two variables that are being populated with this for loop here. We have a variable I and a variable j. So if we start looking at this here, I is populating the width, the line. So that is going to be your x coordinates. So I is going to be in place of the x. Now j is going to do the vertical ones, which is your y. So we're going to put in j there. And now we can run our Ruba program to see if it has a nested for loop with many, many, many Rubas in here. Okay, fantastic. That's all for now.